So first importing from the AutoCAD DXF files actually. So if you're importing AutoCAD from AutoCAD DXF, all the line or polyline in a DXF file will be imported as a beam element. So for example, if you have a straight line in AutoCAD DXF, it is imported as a straight beam element. And if you like a open polyline, actually open polyline with not a closed which a multi thing, that will be imported as a multiple beams actually, multiple beam. And if you're 3-noded or 4-noded closed polygon, so those are imported as a plate elements. Closed polygons are imported as plate, not as beam elements. And if you have closed polylines which are having more than 4 corners, so in that case, that is again imported as a beam element. So everything is imported as a beam element in that case. So only case where you are getting the polyline as a plate element is when it is a 3-noded or a 4-noded. Then you import it as a plate element. In all the other cases, the polylines or the line, it is imported as a beam. And surface and 3D face in DXF file will be imported as a plate element. So solids cannot be imported from AutoCAD drawings because solids cannot be imported. Curves and arcs also cannot be imported. So if you have any curved circle, curve and all those cannot be imported to MIDAS gen. So those things need to be break and exploded in AutoCAD DXF file, and then we need to import the curves and arcs. And also unit system must be consistent between both the softwares. AutoCAD DXF file and MIDAS gen, the unit system should be consistent throughout the things. And also you also can import the grid lines for your reference, and all grid lines can be imported from the AutoCAD drawings using the dimension option in MIDAS gen. This is not import functionality to import the AutoCAD dimension grid lines and all. This is a mainly the grid lines works as a reference in MIDAS gen. So you can import those using a function called dimensions in MIDAS gen. So we'll go through all these functions in detail. Now first what I will do is I will just go to AutoCAD. Let me take a AutoCAD file. So this is my 3D AutoCAD file actually, if you can see. So this is the typical floor plan actually for the building. So we have the grids at the top. So each grid is named in a different names are given for the grids. And then at the bottom you have the column locations, walls are there. So we have drawn a center line for all the columns. A center line is drawn at the column locations to mark the to import into the MIDAS gen. So first thing what you need to do is once your center lining drawing and everything is done actually, first thing you need to check is the units. Just command the units. Check the units here in the AutoCAD drawing actually. What is the units in the AutoCAD drawing? So these units should be consistent between AutoCAD and MIDAS gen. And again, if you are trying to import multiple floor levels, actually multiple floor levels from AutoCAD DXF, each floor plan is different and you want to try to import, then all the floors should have the one common point should be there, which should be aligned for all the floors. If not, then it will be taken at different positions. So you should do the couple of things you need to consider is the unit system consistency. The second thing is the base point for all the AutoCAD drawing should be the same for all the floors. Now once this is the unit system is matching, now what I can do is I can go to MIDAS gen. So first I will go to file, new project. So I'm opening a new project. So directly I can go to file, import AutoCAD DXF file. Just I need to browse the DXF file. So just I will go to browse, DXF import floor plan. I selected the plan which I want to import, floor plan. And here that the center lines I want to import the center line. I selected the center line, the layer which I want to import. So if you have say if you have different beams of different sizes and all, so if you can put it in different layers, so each beam is grouped automatically in as per the layer name in MIDAS gen. So it will later it will be more useful for you to assign the properties and all. So I just added the center line. So the material properties, just I click on the 3 dots next to that and I say add concrete EN04RC and I select C25/30 grade of concrete and I would say OK. The material property is calculated. The section property, add beam, solid rectangle beam, user defined. The height is 0.5 meters and the width is 0.7 meters. OK. Close. And here I'm changing the unit system to mm, because our DXF file the unit system are in mm. So here I'm also changing the unit systems to mm. So once this is done, what is the origin point? You can define what is the origin point. This is the floor plan, the first floor plan. So I want to insert it at the floor level, not at the origin level. So in the Z direction, it should be at 4 meters. My first floor height is at 4 meters. So I gave the origin as a 0, 0, 4. That is X and Y is going to be 0, and in the Z direction, it will be at a 4 meters level. And then if you want any rotation angles and all, you can say if you want to how, and you say okay. See, my floor plan is imported. Now for locating the column locations and wall locations, if you have the grid reference, it will be more easier to immediately pick the column locations and all those things. So for that, what we can do is directly go to the structure, structure tab. There we have option dimension. Now the dimensions, you go to the dimension, say dimension name. Let me say first floor. The grid name, I want to give the grid name actually, so I'm giving, and I'm just selecting the same file again, the floor plan again. So here actually for the dimensions, all the points, the grid lines and the grid marking, I put it in a layer called dimensions. So I selected the dimension, so I can select what is the scale factor, what is the origin point and all, and then I say add, and I would say close. So if you see now, here you have the origin point with all the dimensions and all those things actually. Let me zoom in a little bit so you can see what exactly is the dimension as in AutoCAD dimensions, and you can see the grid lines actually. So this is exactly as per the AutoCAD. So here actually the one thing is like you cannot edit anything in the grid line. You cannot select the grid line also. You cannot select the grid line. You cannot edit the grid lines. Just you can switch it there, turn it on and turn it off actually. Say display and display. Just you can display and you can undisplay. So that is just for your reference purpose. You cannot make any changes to the grid line layer. If you want to make any changes, you need to do it in AutoCAD and you need to import it from there. Once it is in a MIDAS gen, it is like a freezed out layer, so you cannot make any changes there actually. So that is just for your reference. So based on this reference, once I have the grid lines, what I can do is first I will define a property for the columns. Say add sections, solid rectangular, column, user. Say column is 500,000 by 750. Okay. So I can select the nodes where the column locations are coming with respect to the grid line. I can select the nodes where the columns are coming actually. So on the grid points, so I'm selecting my column positions. So I'm selecting the nodes in the columns. So what I can do is once I select the nodes, actually I can extrude these nodes for generating my columns. So I selected the nodes actually where the columns are coming. The columns are selected. Now I go to the properties. So node by element, extrude, node to line element, and it is the element type is planar element or beam element, and the section property is column, and unequal distance in the Z direction. Say let me say it is 4004 meters, that is 4000 mm, and I would say apply. Sorry, it should be minus 4000 actually. So what I will do is select previous, say minus 4000, so that in the negative direction I would say apply. So here the columns are generated actually. So the columns are generated. Even for the core walls also similarly we can do the same thing. So core wall locations, the walls, wherever the walls are coming actually. So in those regions I'm going to select the walls for my walls, the core walls. So this end triangle regions are the walls here in this drawing. So I'm selecting those wall regions, the end walls, and then the central core wall region. I selected all the core walls actually. So here what we can do is it is to be line to planar element. The wall is a planar element. So I say line to planar element. It is a planar element and I don't want the source beams actually. So I say remove. I don't want the beams. I will be removing these beams and the element type is wall type. It is a wall. So I can select the thickness of the walls. Say 500 mm thickness. I would say OK. Okay. Now you can select either it is a membrane type of this thing or a plate. So what type of action you want? When you say membrane, there is no out of plane bending. In plate element, there is out of plane bending is there. So you can select what is the type of the bending you want and then translate in the Z direction minus 4000 and I would say apply. So you can see my floor plan is generated. So now I can go back and I just switch off my grids and display. So now once your floor is generated, what you can do is from here you can go on with the building generation option. If your floors are symmetrical, typical floor for all the buildings. So this floor, this building actually has a typical floor. So in that case, what I can do is I can directly go to the building generation. So I have 16 floors above this, each one of 3.15 meter height, 3100 height actually. And I would say add. I would select the complete building and I would say apply. So the building is generated. So here, a couple of things you need to you need to understand is before generating the building, if there is a loadings and all are there, I can apply all the loadings on the typical floor itself, and then I can generate the building. So in that case, what happens is my load and everything gets copied to all the floors. Or the other case is after generating the building, so you can also apply the loads on this building right now. So loading and all we will be discussing more in detail in the next webinars actually, where we are going to do a series of webinars. So this today's webinar I'm going to concentrate only on the modeling, how to generate a model, how quickly you can generate a model in MIDAS Gen. So this is one way of importing a 2D DXF file and then a grid lines, reference grid lines, and then based on that how to pick the column locations, wall locations, and generating the drawing. So the second way of importing the drawings from AutoCAD is it's not only the 2D file, you can also import directly a 3D DXF file. So for example, you have a 3D file in AutoCAD DXF, 3D model. So this is a 3D model which is a 40-story structure. So I can directly import the complete 3D structure itself with all the columns, slabs and everything from the 3D model. So the procedure is the same again in MIDAS Gen actually. So the procedure, there is not much of a change. So again here also we need to, first thing is we need to check the unit systems. The unit system should be consistent between these two. Say UNITS units. So it's a unitless system. I'm changing it to millimeters and I would say OK. So now I go to MIDAS Gen. So I would say new file, file, import, AutoCAD DXF file, browse. I mean, see, I'm browsing the 3D DXF file. So in this 3D DXF files, what I did is I created different layers actually for my beams 350 by 750, the beams 400 by 800, beams 450 by 900. I have different layers. So here one advantage is there when you're importing, there is no need to import everything at a single go actually. So first let me change the unit system to millimeters. Yeah, millimeters. So first let me select the slabs. So I selected the slabs and I'm going to the material, add a material, say concrete. My slab is of 30 grade, so I selected 30 and I would say OK, close, and the thickness of the slabs add 250 mm thick, 250, OK, OK, and I can click apply. So all the slabs are imported with the given thickness actually. So if you have different thickness of the slabs, if you generate different layers in the slabs also, you can import one by one by assigning the thickness and everything while importing itself actually. So another, now the slabs are imported. Now what I will do is I will go for the beams, say 350 by 750 beam. So I will just go to the section, add, say solid rectangle, beam, user 350 mm by 750 mm, the beam. Sorry, 750 is the width, height, and 350 is the width. Okay, okay. This is my beam 350 by 750, and I would say apply. Sorry, it should be in mm actually, the units. Okay, the unit should have been in meters. Okay, now you the beam properties. Just I would say beams, and I would say apply. So the beams are imported. Similarly, you can import each and every layer by giving different properties. You can assign each and every layer, and you can import the. We can import the things from here actually. Or the other way of doing this thing is, what I can do is just let me undo the complete model. Instead of selecting each and every element separately and updating all these things again and again, actually, what I can do is directly just let me select all. Okay. So the other thing what I can do is just directly I can go to file, import AutoCAD DXF file, say browse 3D DXF file. I can import all layers in a single go without assigning different properties and all. I select all the layers and I just give the thickness for the slabs as 250, and for the beams maybe I create only one single property actually. So solid rectangle 350 by 750 beam. Say user. So what happens in this case is all the beams which are being imported, they will be having the same property. So I would just say okay. So imported the complete model. Now for each beam layer name is created as a separate group. So once the model is imported here, you can select the group and you can assign the properties, required properties. So that is the other way of modeling when you are importing a 3D file. So one is you select each layer wise and give the respective property and import that each layer wise you can import, or you import the complete model. So each layer is created into group. Later after the model is imported, then you can give the properties to the groups. Select each group and assign the properties. So as it's a 3D, it's a big structure actually, it is taking a little bit of time. So here the model is there, complete model is there actually. So let me say it is. Okay. Now here you can see actually. So all the beams, all the columns, all everything have the same property actually, which we have given in the previous location actually. So here what you can do is just if you right click tree menu 2. So here you have the groups. So here you can see the groups. So each layer is created into a group. Now what I can do is I can go to the section properties, add sections. Say directly I can go to the solid rectangular. Say EC 1000. So that is the user. It is solid circular column. Say 1000 actually. Apply. Similarly, I have EC 1100. EC 1100. So I would say apply. Similarly, EC 800. So I can go on creating the properties actually here. So once the properties are created, what you can do is directly you can come here, double click on the layer here in the groups. Double click. Those elements are selected in the model. The red color highlighted one are the elements. Just drag and drop the required property there. So the properties are changed. So double click, drag and drop the required property. So in that way you can do the assignment of the properties actually. Click, drag and drop. So this is one way of changing the properties and all. So one is while importing you can give the properties and all, or after importing you can give the properties and all. So this is in brief about the AutoCAD import functionalities in the program. Either if you are importing a 2D file and creating a building, or you are importing a 3D location. Now I will I have a couple of queries on this features actually. So if you have any questions before going further with the Revit structures, if you have any question regarding the AutoCAD, what we have discussed, you can ask me now. One is from Mr. Levi Cuno. Why the Z coordinate is in meter while the dimensions are in mm? Sir, actually when I stayed import at the time, what happened is actually the unit system is in meters. So I entered the Z axis in meters actually. say in 4. So later by 4 import I change it to mm. So when I change it to mm, you can see the value will also change to mm actually. It automatically converts to 4000. So that is just a mistake from my side actually. Before changing the units, I entered the dimensions. So later I changed the units. So there is no need to worry actually. Even the coordinates, if you enter in one unit, later you are changing the unit to some other unit, the value will be automatically updated. Okay. Now here you can see it is showing 4000 in the origin. So if I change again the units to meter, it automatically comes back to 4. So that is automatically taken care. Okay. And coming to the other question, from Mr. Rafid Atra, how can we choose the correct principal axis? Sir, principal axis, once if you know the principal axis in AutoCAD X and Y, XY direction, Z axis is the vertical axis in AutoCAD actually. So if you have different axes actually, we have the rotational functionalities in the program. So for example, your drawing is not exactly in the XYZ coordinates in AutoCAD actually. Maybe in AutoCAD your Y coordinate is the vertical, you kept it as vertical, and X and Z you kept it as horizontal. So in that case, what you can do is when you are importing the model from AutoCAD, in MIDAS we have this rotation angle Rx, means it rotates the model with respect to the X axis. Ry, it rotates the model with respect to the Y axis. Rz, it rotates the model with respect to the Z axis. So you can give the rotation angle, you can manipulate from here actually. So if it is in the XZ plane, so here it is, we want that in a XY plane. So that is, we need to rotate it in respect to the Y axis 90 degrees. So you can give 90 degrees with respect to the RY rotation, then your plan will come in the XY plane here. So that way you can manipulate the principal axes from between AutoCAD and MIDAS Gen. And the next question is, how can we believe this is the critical axis? So critical axis, that way actually there is no right way to say, but you need to check both. You need to first check the AutoCAD drawing, what is the plane, in which plane your floors are laying in the AutoCAD drawing. So either it is in XY plane or XZ plane. So that gives you idea along which axis we need to rotate. So for example, if it is in XY plane, so in MIDAS also the vertical plane is XY plane. So there is no need to rotation. But if your AutoCAD in AutoCAD, it is your plan is in XZ plane. So we need to rotate along the Z axis, that is the vertical axis, should be rotated along the vertical axis so that you can get it in a plan form, that is XY plane. So you need to rotate along the Z axis. So that you need to compare both AutoCAD and this thing, and the engineer need to come to that judgment, sir. Which axis, how the rotation will be happening. Hope this is clear. Okay, now let's go to the next part actually. So as I said, actually one thing also, when you are importing the grid lines, those are for references. You cannot change anything in the grid lines, and the unit systems between both the drawings, both AutoCAD and MIDAS Gen should be consistent. And curves and arcs cannot be imported. Solids cannot be imported. 3D face and surface in DXF will be imported as a plate element. And closed poly, 3-noded and 4-noded closed polygons are imported as a plate elements. And all the other types of lines are imported as a um, solid elements actually. And another question from Mr. Amar Dosari. What about the openings in slabs? Sir, if you're providing an opening, say if you're modeling the slab as a, for example, if in AutoCAD, if you're modeling the slab as a 3D face and you're providing an opening in that, the opening is also taken care by the program. Automatically, it will import the opening as well. If it is modeled as a 3D face. But if it is modeled as a closed polyline, again, internally, you need to create another polyline actually, which is not a polyline, which is 4 lines, which makes the boundaries of your opening. So in that way, you can take the model from there. Like that, you can take the openings in the slabs. If it is a 3D face, you directly model the openings in the 3D face element itself. If it is a polyline, closed polyline, then create a boundary inside that closed polyline with lines, not a polyline with lines. So then the openings can be imported. And another question from Mr. Livy QNO, how the arc elements be manipulated in importing to MIDAS from DXF? Sir, arc elements, one thing is we need to break it into smaller parts. either by using the explode function, or we need to break it into smaller parts, arcs, circular elements, curved elements. These need to be broken. So once you broke into small parts, you can take into the here. Yes, sir, arc to multiple lines. You need to convert into multiple lines, the arc.